In the figure here, we have two circles with equal radius and one circle passes through the center of the another circle. That means blue circle passes through the center of the yellow circle and the yellow circle passes through the center of the blue circle. We have to find the radius of these circles if it is given that length of common chord PQ is 17.3 centimeters. Let's discuss the approach for doing this question. So here we have to find the radius of the circles, so somehow we will have to relate the length of common chord PQ with the radius of the circle. Let's suppose center of the blue circle is point X. Let's draw XO perpendicular to PQ from center X of the blue circle. Now perpendicular from the center will bisect the chord, so length PO will be equal to length OQ. Let's join PX to complete the right triangle POX. Now PX is the radius which we need to find in this question. We can call it as R. And we know that PO will be half of 17.3 centimeters. So in right triangle POX, we can apply the Pythagoras theorem if we know OX. But how can we know OX? Let's try to find out. Now if we extend XO, this will pass through the center Y of the yellow circle. As XO is the perpendicular bisector of the chord PQ and PQ is the common chord, so its perpendicular bisector will always pass through the center. So point Y will be the center of the yellow circle. Now we can join X to Q, Q to Y and Y to P to complete the quadrilateral. Now what can you say about the nature of quadrilateral PYQX? Well, all four sides are equal in this quadrilateral, as PX and QX are the radii of the blue circle and PY and YQ are the radii of the yellow circle, and we know that radii of both the circles are given to be equal. So the important property of the rhombus is that its diagonals bisect each other at right angles. So from here we can say that if XY is the radius small r, then XO will be r by 2. So we have found out what will be XO, and now in right triangle POX we can apply the Pythagoras theorem. So applying Pythagoras theorem in right triangle POX, we will have square of the hypotenuse is equal to sum of the other two sides, and hypotenuse here is r, so r square will be equal to PO is half of PQ, that is half of 17.3, that will be whole square here, plus OX we have found out to be r by 2, so we'll have r by 2 whole square here. So by simple calculation, we can find the value of radius r here to be 10 centimeters. And this is what we had to find in the question. In this problem, we applied the properties of chords and diagonals of rhombus to solve the question.